Thank you for sticking around after lunch. um, but really excited to present this work. um, Drones have all kinds of wonderful uses, but we've been really limited for the past while of flying within the visual line of sight of the pilot. As of November 5th, there's new Transport Canada rules that allow, under the right circumstances, flying beyond the visual line of sight of the pilot. So we're relying on the drone to not crash into other aircraft. That'd be nice. And to maintain communications with the responsible pilot somewhere on the ground. Drones are lighter, less expensive, both from capital and operating costs than piloted aircraft. Of course, you don't have to carry a pilot in the air. Quieter and greener too. Now, the way we would want to operate a drone, for instance, for a pipeline or utility inspection, is buy a drone with a 100-kilometer range, fly it out and back, and you're good. But if you need to have a pilot within visual line of sight, you end up with a drone, two trucks, and they're driving leapfrog 1 mile section lines following the pipeline, two operators handing off control. That doesn't save you any fuel. There's so many applications, multispectral imaging for agriculture or forestry. That's not right. Here we have a normalized differential vegetative index for a field we flew over with a specialized multispectral camera we developed. First responders, and we'll be hearing from the RCMP right after this. Missing persons, crime and accident scene investigations. It would be great if we didn't have to have the operator right there. Wildfires. You want to know where the fire is through all that smoke. So you can direct the fire suppression, the water bombers. And if you're doing that, you also have to sense and avoid. Well, I've found out that the RCMP were providing assistance to the Jasper fires to the mop-up for the hotspots, but not in cooperation with other manned aircraft. It's been one or the other. So requirements for beyond visual line of sight, and whether you call it RPAS, UAS, or the media prefers the term drone, all the same thing. November 4th, rules change. We can operate beyond visual line of sight. Requirements, you consider a regular piloted aircraft. The pilot is using their own eyes to look out for other aircraft, obstructions, structures, terrain. They don't want to crash and their life is on the line. So following visual flight rules, looking. Human eye is a totally amazing instrument, that with human perception. Cameras aren't nearly as good. Of course, drones must sense and avoid no mid-air collisions, crashing into stuff. Cameras are not a great solution. LiDAR is popular for self-driving cars, but pretty heavy and energy intensive. Radar would be a great solution, but we still need to scale it down to fly in everyday drones. The other thing we need is communication with the ground station. When you're beyond the horizon, most of the radio links don't work. Could use satellites, but the cellular network is already built out. It's there. Thank TELUS for the coverage they have of Alberta, more than half. And most of the areas don't have coverage, don't have roads any either, so you're not going to get out there. For our communication, we use hybrid 5G telemetry command and control. You can buy commercially 5G solutions. We are flying with open source drones, and we need to be able to control that, so we've spun our own. Cellular network gives us a range wherever there is a cellular network. 5G is preferred, of course, for low latency, high data rate, and high capacity, so you can fly a lot of drones. Hybrid 5G plus a point-to-point radio, that gives us backup. We replaced all this complicated electronics with a latch, and we discovered that we can latch and do direct binary sampling at 24 gigahertz. So imagine, instead of a color image of where you're flying, a 2D view of what's ahead with objects, obstructions, other aircraft that you prefer not to hit, color coded by their depth. That's the image we can provide you. More important, for the machine, doesn't care about the color coding. We are providing a 3D representation of all the objects, and that gives you the ability to fly around, avoid fatal mid-air collisions, and damage to the drone from hitting structures. To do this, we had to develop a new chip with the new radar architecture. So we have a functional 24 gigahertz chip with multiple channels on it, and first stage DSP as well. This summer, we'll be simulating the flight of beyond visual line of sight by flying laps around South Campus in the TELUS provided 5G Living Lab captive network. Using basic radar sense and avoid. And I'm challenging the students in my lab, do this in the dark in smoke. This, of course, is a first-person view drone video off YouTube, but we want to be able to navigate complex obstacles using radar with the increased resolution. And I understand before the chat, RCMP Inspector Corey Blythe has a short presentation of his own on how first responders are using drones.
You bet. Normally this takes me about 60 minutes and I could talk about drones all day, but I'll try to keep it down to the 10 there. So we're just going to go through basically what we're doing within the Alberta Police in regards to RPAS. So I'm the officer in charge of air services with the RCMP. I'm based out of the Edmonton International Airport. We have a hangar there. I've got crewed and uncrewed aerial assets. We basically have a helicopter for the province and two PC-12 Pilatus transport planes. So Duncan kind of went through this already, but I'm in the RCMP, as you're well aware. I'm also doing stuff with military, and I'm also in the air world, so we love acronyms. And nobody knows what the acronyms know between the different programs. So basically in Canada for flying drones, we're usually call them RPAS or remotely piloted aircraft systems. For the most part, we're using a number of different platforms, which is the main one is the quadcopter. We do use fixed wing assets, VTOL, within the nation. And also we do have hybrid systems, being that they will operate on various different fuels and for the most part, electrical. And of course, each platform is good for various operational needs. So in Alberta, this is what we're striving to do. So we have basically 4 RPAS programs. The first one is the specialized units, and this is where we started back in 2012 in a lot of places, is with our traffic reconstructionist program, doing the 3D mapping, modeling of collision scenes, usually because of a fatality. And then the next ones that came on board was our critical incident program, which is basically our emergency response teams, which is the American version is the SWAT teams, the seldom working, always training guys. And then, of course, it picked up from there with, we have our explosive disposal unit that uses them now, even our strategic communications, of course, doing various videos. And now with increase regarding border stuff and all other stuff, besides the Blackhawk, they have a number of drones that they're deploying for the increased enforcement there. So in Alberta, it's basically contract policing, and there's the federal end of things where the federal monies fund that program. But majority of the contract is either a provincial contract or a municipal contract. Any municipality over 5,000 population, they have to provide their policing. And that's where they can contract the RCMP. So Strathcona County would be a perfect example, because they're over the 5,000 population limit, they contract the RCMP out. And of course, the provincial contract is with the province to provide policing services for Alberta. So the second program is that municipal program. So if a municipality wants to invest into RPAS technology for doing policing within their community, they have that availability to do that. We haven't done it yet, but we're looking at Indigenous communities of a separate program. And I'll talk a little bit more about drone as a first responder, especially in Indigenous communities where we don't have an actual physical detachment. We can basically launch drones remotely. And then basically the district programs, there's 4 districts within the province, and this is all on the provincial aid side, where we do have a drone program for that. And then the last but not least is the actual division RPAS unit. Presently, it's pretty much me, but we are requesting 6 regular member officers to form that unit, and we would be providing that program leadership and operational support. So this is what we're trying to strive to, is basically deployment models. So I already talked about the specialized units. It's going to be specialized to what they're doing. For an example, in that one is collision. So the collision analysts will do their thing. On the district and the municipal side, we have the patrol-led deployment that we currently have, and that's where the pilot pulls up to the scene. They're usually just your general duty member. They're trained to be as an advanced pilot, and they will utilize that drone from off the passenger seat and fly the mission. We do want to go into patrol-led drone as a first responder, where very similar to the patrol-led, member pulls up the scene, they launch the RPAS, but then remotely somebody will take that over. So now I have another investigator that's on the ground that can be part of it rather than flying. And somebody in a communication center somewhere can take over that. And most of the remote piloting is through web-based browsers. And of course, that's where potential 5G connections can come into play, or SAT connections. And then dock-based drone as a first responder. We did trials last year in Lac La Biche, Red Deer, Stoney Nakoda. They were very successful. This is where you have a dock that is going to be on a location. It could be the detachment, or it could be any city building, or whoever we partnership with. And that drone can then be remotely launched from that dock and go to a location. And so that would be through a communication center or whatever program it is, how they want to set it up. And um, majority, 50% of the, more than 50% of the time, the drone is actually the first responder over an actual fire or police officer showing up to the scene, because of course they don't have to worry about roads and stuff like that. So I'm just going to show you an example of how we use RPAS for public safety and for officer safety. So this is basically a police dog services. This is a training scenario, so that's why you'll see some finger guns probably. Um, but it's just basically a demonstration of how that can work. So you have your dog team and his backup going. He goes out, switches to thermal. So you can see the team there. And basically, they're looking for a suicidal person that has gone missing. So as the pilot goes ahead of them, he or she is looking for anomalies. So right here, you kind of see a hot spot. I know that's going to be a culvert, but then there's this hotspot anomaly that the pilot picked up on. So they switch to their camera, and there's the potential suspect right there. So the thermal helped them locate the anomaly. The camera let them kind of see. So now they're communicating to the police dog team that this person's up ahead. So that gives them time to set up. How are they going to de-escalate the situation? How are they going to approach this person? Whereas traditionally the dog would be tracking that person, and the dog may stumble across the person, and now we have a potential a situation where the person may be upset, the dog's going to be barking, all this other stuff. So now we can take our time and deal with any threats that that person may have against themselves or against others, and make a plan and deal with that. So that's just an example there. So one of the biggest things we've learned, and this has come from knowledge of within the United States as well, is addressing those privacy and ethical concerns. So a lot of our time is addressed doing talks like this to educate people how we're using the drones, but also through the media, through town councils, all other stuff, just to talk about their privacy concerns. Well, you were watching me in my hot tub. I think I got better things to do than fly around looking for people in hot tub when I'm actually looking for bad people, right? So we do have pretty strict policies regarding surveillance techniques. So it's not as if we're flying drones, patrolling and looking for stuff. That's not the way the program's built. So that's where we do a lot of work in the places that we do have the drones in, to basically make people understand how it's used. Because that lack of communication, that's where people make up stuff. And even when you communicate, some people will make up stuff, but at least we're ahead of the game. So, and then just in that effort of building that public trust. So some of the future trends, there's a lot of talk about integration of AI and machine learning to revolutionize that stuff. As the technology grows, I've always said basically we have a flying smartphone, and then we're just attaching hardware and software to that device to meet the objectives of what the missions are. So automated search patterns, there's a number of different search techniques. So future AI could identify, okay, this is the best way to point the gimbal, and this is the best pattern to use, whether it's a sector search or a rising ladder search or any of those things. And provide that enhanced decision making. A lot of the remote can be done autonomously, and then we take over manually once we get to the location. So, but on the other hand, as the more of the fixed wing come into play, a lot of that is just strictly autonomous, and then you're just changing or pointing the camera payload somewhere else. And of course, where does that come into play with AI identifying anomalies by looking at the pixels and identifying those anomalies to improve our target detection, whether we're looking for an evidence or a person or any of those other things. So a number of different payloads are already being used out there. So we do have gas sniffers. That way we can fly a drone into a hazardous situation and identify if there's any hazmat materials there. Um, there is LiDAR payloads that are being utilized in some locations, especially in border operations, those kind of things. And of course, that enhanced sensor technology, high resolution cameras, as it goes, it's getting better and better, especially some of the things that are changing is normally you have thermal, you identify anomaly, then you'd have to switch like I showed you in the video there. Now you can actually, the thermal cameras are getting better where you can actually have a better zoom product with the thermal. You don't necessarily have to switch out. Some of the older technology can't have target tracking, so you can just draw a box around the target and it'll track that target. You couldn't do that in thermal before. You had to switch to your camera, do that, and then just keep with the camera. But now thermal imaging is allowing you to do that on some technology. And of course, that LiDAR technology. So of course, that's what we're also looking at is integration of the RPAS with other things like satellite imagery, ground sensors, a number of those different factors. How do we give the most situational awareness to our police officers on the ground and to the people that are making the decision maker in larger incidents? How do we incorporate all this data into one? And that's where our real-time operations centers are utilizing various software such as our RFUS, other things that are off the shelf right now to basically bring all that data into one place and then try to figure out what the best way to use that data is. So a company called DroneSense, they have a system called Ops Hub. You can actually bring in the Esri layers, and so I can access all the CN police or CN rail cameras and be able to look at those cameras. Or also our 511 Alberta Roads Network could utilize those cameras to see what the situation is there and stuff like that. So do we have a few more, like one more minute?
Yep.
Okay. I'll come back to this if you want the information, but we'll just play a video, and this is basically in Red Deer and just shows you a dock system. So that yellow canister there is actually a parachute. That way we can fly over people, and under certain parameters, if there's a failure, it'll actually deploy that parachute if that way it lands somewhat nicely rather than falling on somebody's head with sufficient force. And then of course it has its own weather station there. You can see the for the wind there, and there's cameras that you can see within the system itself. So thank you.
When we discussed this talk earlier, you guys mentioned kind of unrestricted airspace and restricted airspace. So I can almost imagine, again, if we all close our eyes and we imagine now more than just kind of one drone in the air at a time, right? What does that mean from a collision perspective, but also from the regulatory perspective? How is regulatory catching up to potential various uses of drones and the potentially more busier and busier airspace that we have above us? You have any comments on that, Corey?
Yeah, so we're working with Transport Canada and Nav Canada quite regularly, so we can operate what's called a special flight operations certificate. So in some situations, we've actually have attained BV loss already through that special flight operations certificate. The changes that are coming up with the Canadian aeronautical regulations in November 4th, that's going to open it up more for industry. But Transport Canada has always been working with us just on the simple fact that public safety. And of course, it's becoming especially on our side, they're going to look at providing us airspace when we declare an emergency. So uh, normally that would be done through something called a NOTAM, Notice to Airmen. But of course, it's a very laborious process. So they're looking at ways that we can announce that it's an emergency and no drones, no aircraft go through there. 2 years ago, I was the search manager for a search for a missing boy out at Fishing Frog Lake. And all of a sudden we have this Cessna kind of bombing through, and I had one Canadian Armed Forces helicopter, I had my helicopter and 3 or 4 drones, and trying to manage that airspace. And then all of a sudden this guy comes zipping through there. So we are working with that. And of course, that's where technology will come into play. So there's a signaling system called ADS-B that's for planes. There is talk about having systems that would signal drones and stuff. So through an ADS-B, through my hand controller, it'll actually, if a plane is flying ADS-B, give me a warning on some software systems that there's a plane coming through. But of course, they're at like 10,000 feet, so I'm not even close to that. And that's where, once again, having those altitudes kind of deconflict the airspace. So, but deconfliction is a big space, especially in restricted airspace. So, Calgary Police Service has actually worked out stuff with the Calgary Airport because they have quite a bit of restricted airspace with their helicopter, and they're starting to get into the RPAS systems a little bit more as well.
So having seen Duncan's presentation, do you foresee kind of newer technologies like, and potentially intelligence on these kind of unmanned vehicles be able to kind of avoid collisions themselves?
Yeah, so that's where the software will become very important. What detection systems are on board that RPAS system? That's going to be a big one, because then right now, for the most part, for detect and avoid, you have radar, acoustic, cameras, and radio frequency. And usually it's only good for about 2 nautical miles. For what the stuff we're doing now, it's pretty good. But when you start doing a whole province and you'd like to have long range RPAS in certain locations, then that doesn't work. So, so policing a big province, it really comes into play if we get those technologies and those systems. It can literally be a game changer.
Okay. Yeah, so the next question I want to touch on is really, and we talked about this, is really access to this technology, drone manufacturers. Now, we mentioned DJI, and kind of again, I'm assuming the RCMP no longer able to procure from DJI, but kind of, what options do you have to procure new drone technologies?
Yeah, so we've been shut down with DJI, and DJI for the technology and for the price, you can't necessarily beat. That's why they have 85% of the market. We are looking at other technologies such as Parrot and Affy, which is a French company, and part of it is the issues with the states right now. That's one of the reasons we're looking at it. And then of course, Skydio is another manufacturer out of the states. We're testing a few of their systems, but a lot of it comes down to our procurement process. So it's the procurement process kind of identifies at the end of the day, and that can be problematic at times, because I've seen procurement actually purchase drones and then they just sit on the shelves because they don't meet the requirements. So those are some of the challenges there as well.
So do you foresee kind of a local, let's say, Western Canadian based company that could actually service and design drones to your specific specifications and advantage?
Yeah, so there is a number of companies that are doing things. It's just not to the scale that, and the other part of the issue with the Canadian environment is they're not necessarily marketing themselves specifically to law enforcement. So you kind of get it from word of mouth. So we do have some very good companies out there. We are actually using a Canadian company for the fixed wing VTOL that's going to be used at the G7 conference this summer. And they're supplying 3 systems for that. but that's the other reason is it's only 3 systems, not 85. So
So Duncan, hearing this and seeing that, U of A, we're able to kind of produce these, and design these new components and these new advantages to drones, do you potentially foresee a commercialization pathway for some of the technologies you're developing?
I certainly hope so. We've been talking to 2 drone manufacturers in Alberta. Want to prove the technology as within the university and move it out. My $50 million of venture capital has followed some of my patents. Got me a house, not a retirement, so I'm still hungry. There's have been some good startups formed in my lab, and if we can do it again, that would be great. Certainly, the manufacturing of chips won't be done locally. We get our chips manufactured the same place Silicon Valley does, Taiwan Semiconductor Manufacturing
Right.
Corporation. But it does make a good case for a fabless semiconductor company if there's success, and I think there's the demand.
Right. So now talking about the radar technology, so collision and detection and avoidance, but once you get to a scene, you can also continue using that sensor to actually map out. So what advantages would have, using a radar technology at a scene that both of you can kind of comment on?
it gives you another aspect, right? So it's just like if you have your camera and then you switch to thermal, it's giving you a different data. So the same thing, if you have a radar system, it would detect things that you may not be able to see with the visible eye. Just like bringing in AI software to look at each individual pixel to identify anomalies, that would be another big thing as well if you had the processing power and everything else like that, right? So that's where it takes in possibly all 3 components and then gives you a better picture of what you're dealing with. And because it's the human factor of looking at cameras and whatever data, then it's basically human factor. Somebody isn't paying attention and misses something, things like that. So,
Right. And this is basically, you mentioned payload, basically another payload option that you would have. Yeah, Duncan.
Yeah, this is remote sensing, and radar is just another dimension of that. Imagine looking for shell casings in deep grass, or a child who's gotten lost in a cornfield. If you can't see through the leaves, the radar can, and they could detect an object above the ground.
Right. And what about, again, Duncan, you mentioned in fog and weather, are those advantages that you see kind of with a different type of sensor like radar?
Absolutely hope so.
Can you explain a little bit of why that is?
Well, it's all electromagnetic radiation, but fog scatters light, smoke blocks light. The radio waves will go through smoke and fog, whiteout snowstorms.
So, Inspector Blythe, was there a situation where you weren't able to use a drone system because of weather or environmental factors?
yeah, if it was just straight camera payload, yes. So of course, thermal is very similar, where it can see stuff that because of the heat changes and stuff like that, as long as the everything else is not affecting the sensor. But yeah, there's definitely, the more data you can get, the better you're going to get for mission outcome.
And a final question was actually, this was quite interesting in our conversation earlier, was that you mentioned you actually do use drones indoors as well.
Yep. So mainly FPV drones. So right now we're using DJI Avata 2s. for indoor, clearing indoors. That way we don't have to send in a person, and that's why we have police dogs, is we used to send in a police dog, but it's another life. So now we can use indoor drones to go in and clear a building. Some of the newer indoor drones that are a little bit bigger and pricier can actually do that 3D mapping of the interior. So you kind of have an idea of what the layout of the building is. So there's a lot, and some of that is actually using LiDAR. So there is those various things that are available. The reason we use the DJI Vata 2 is because it's a $1,200 drone. So when it hits, that baseball bat hits it, it's easier to replace than the $32,000 drone. So yeah, we're using those for our critical incident program.
Okay, great. Well, thank you both of you for kind of that insight into kind of where the technology can potentially drive into more and more useful applications. So thank you to both of you.